Welcome back, folks. In the last video, we took a look at three shortcuts that we could use if we're trying to prove two triangles congruent. They were the SAS postulate, the SSS postulate, and the ASA postulate. SAS standing for two sides and the included angle, SSS standing for three pairs of sides, and ASA standing for two pairs of angles and the included sides. So having those things congruent makes two triangles congruent. So now let's look at this proof. We are supposed to prove in this proof that these two triangles are congruent, triangle QSM congruent to triangle MPQ. And what we're given is that SQ is congruent to PM and that angle SQM, again, we can't just call this guy angle Q because it's not specific enough because there's more than one angle using Q as the vertex. We have to use this longer name. Angle SQM is congruent to angle PMQ right there. So if we just look at this before we just jump right into the proof, we'll notice that in all three of these shortcuts that we learned in the last video, we need three pairs of things congruent. And what we have here is we have two. We have one pair of sides and one pair of angles. So if we could either add a pair of angles or a pair of sides, if they're the right angles or the right side, the correct angles or the correct sides, then we would be able to use either maybe ASA or SAS. And I also told you in the previous video that one of the things you have to watch out for as we're going through these lessons here is you have to watch out for triangles in a diagram that are going to share a part. And you'll notice here that both of these triangles, they use segment QM, right? They both use segment QM. So we could say that segment QM is congruent to itself, which would be another pair of sides. So that would give us one pair of sides, two pairs of sides, and most importantly, it would give us the included angle, right? Because if I kind of draw in, okay, PM is going to be congruent to SQ by the given information, and then this angle right here, sorry, let me get my writing utensil back. This angle is congruent to this angle. You can see that that red angle is the included angle between the orange and the yellow and the orange and the yellow. So we should have enough information to use side angle side. So let's start writing that out. First of all, we have SQ congruent to PM and angle SQM congruent to angle PMQ because of given information. Next, we realize that segment QM is congruent to itself, and that reason would be the reflexive property. The reflexive property. And so now what we look at is we have a pair of sides, a pair of angles, another pair of sides, and we've determined that these angles are the included angles between the sides that we've named congruent. So that means that we can say that triangle QSM is congruent to triangle MPQ with the reason side angle side. So a pretty basic, straightforward proof there using side angle side congruence. In the next example, we're going to do something similar. We're trying to prove two triangles congruent. We have some given information. So if we kind of try and make sense of this given information a little bit, let's say we have AC. I'm going to color code these. AC is said to be congruent to EC. And we have DC that is said to be congruent to BC. And then the other piece of information they give us is that AE is perpendicular to BD, which means that there's a right angle there. But there's not only a right angle there, it means there's right angles there and there. So we might be able to go that route. But we might also realize that these angles would be congruent to each other because they're vertical angles. We wouldn't even actually have to know that they're 90-degree angles. And so if I have these pair of angles, I have a pair of sides here and a pair of sides here that join together to make those angles, we might notice that we actually have side angle side without even using this bit about the lines being perpendicular. So let's write out this proof. First of all, we're going to use the fact that AC is congruent to EC and that DC is congruent to BC as the given information. Then we're going to say that this angle right here, I can't call it angle C because there's too many angles with C as the vertex, so I have to use its longer name. Angle DCE is congruent to this one over here, angle ACB. And why? Why are they congruent? Because vertical angles are congruent. And then that gave us enough information to say that triangle ABC is congruent to triangle EDC. Why? Well, we had a pair of sides here, another pair of sides, and a pair of angles. And we determined that these angles were the included angles between these sides. So that means our triangles are congruent by side angle side. All right, so a couple pretty simple, pretty easy, straightforward three-step proofs there. Both of them ended up using side angle side. And so hopefully that can kind of help you understand a little bit. Of course, we have to watch out for triangles that share a part, and then that would be congruent because of the reflexive property. Also, you'll see a lot of this, angles that are congruent because they're vertical angles. So a couple things that you can watch out for as you're trying some proofs on your own. All right, we will see you next